Right, welcome back, and welcome back to our panel discussion here. Once again, this is a really heavyweight panel of AI expertise, and we're going to go through some questions today that have come in. Some of them through a feed loop, and some been fed into us prior to the event at the end of the day. So I'd like to briefly introduce our panel. We've got Trevor Burbridge from BT. We have Kes Ward from the Lancaster University, Professor Sam Madden from MIT CSAIL, Ben Taylor from CTO Rainbird, and I'd also like to introduce Merve Alanyali Rafferty. I hope I got that right, Merve, from Liverpool Victoria General Insurance, who's joined us on the panel discussion. Merve is the head of data sciences and academic partnerships at Liverpool Victoria, and has a really fascinating background in terms of computer science, complex systems, and behavioral science. So you got a really interesting perspective on this at the end of the day. So first question I want to ask, and I'll come around to each of you on this. We had some discussions yesterday around data quality, and a lot of the discussion today was around auto detection and building those other kinds of models and well. But what's the biggest challenges in actually improving the data quality at source? Because I can see the problems amplifying as they work their way through the models at the end of the day. Yeah. So what I'll do in the first instance, Ben, can I at Rainbird, can I start with you, Ben, first to have a crack at that one?
Sure thing. I think you're absolutely right. I think the issue of particularly when we talked earlier about biases in data, I think that the risk of biases being amplified through data is very real. Particularly, and particularly the kinds of things that we focus on, which is about making end-to-end automations starting from data, where those data are very often the result of collecting prior human judgment. So maybe you're making decisions on the basis of decisions that where people have made those decisions that have gone before you. So I don't know, making decisions about insurance claims, for example, where insurance claims handlers would have made those decisions in the past, and we're basing our decisions on that. It can be very difficult to understand where there might be biases in those data, or where maybe those people were not making decisions on the best basis, but then we're training systems from that in the first place. I think that is a real challenge and requires real deep understanding of the way in that particular example, your handlers or whoever it might be is making those decisions in the first place.
Okay, great. Thanks, Ben. I know, Merve, you were doing lots of violent head shaking there. I mean, do you have something to add to that one? Yeah.
Yeah, definitely. Human biases, measuring fairness, creating frameworks around fairness. One thing I guess I can add from our side that we discussed it within our team, one big challenge that we actually hit is the lack of sensitive data that we have to measure the bias when you actually come up with a fairness metric and you have your bias mitigation framework, but how can we actually measure the bias? So we're not collecting all of the sensitive data. It's not ethical necessarily to go and collect that data and ask our customers. So the biggest challenge is how can we measure it? And I guess one conversation that we having internally, which we kind of find quite valuable, is having a very transparent and open conversation with our subject matter experts and the rest of the business, and getting their opinion on it. Them also understanding how our models work, so how they can use the models, so that they can actually give the best of their expertise to us. And I guess we're also quite lucky in a sense that it's quite ingrained in the culture of LV, for example, having the customers in the centre. So no one actually wants to have bias in their decisions. So having that open, transparent conversations do help, but this is one of the challenges that we're facing.
Okay, great. Thank you very much for that. Merve, Sam, do you have any comments to make on that?
No, I mean, I think I agree with the points that have been made. I mean, bias is just this horribly hard problem, right? Because, it's not that the algorithm is biased, it's that the data is biased, and it's really hard to get data, especially data that's generated by humans, doing things that doesn't have some kind of bias in it. And so, the algorithm just learns whatever you give it. And so, I think it's these kinds of topics that a lot of the folks here have been working on are I think critically important. Like how do you understand and detect this kind of bias. And yeah, I mean, the outlier stuff we talked about, I mean, it doesn't necessarily help in this case, right? Because these biases, they might not even show up as anomalies or outliers in the data. It might just, might look like your system is performing perfectly normally, and yet, it's producing some kind of a result which is quite, has this baked-in bias in it. So.
Okay, great. And I guess, Trevor, given the kind of work that you're doing, particularly at BT, is bias that really a big issue for the kind of work that you're doing at the end of the day? Or is it one of those things you don't have to worry about too much given the nature of the work?
I think different forms of bias. So where I'm dealing with network and service platforms, we don't typically have that sort of customer confidential information, bias between male and female and ethnicity and these sorts of things. But of course, there's bias in any data set. So for example, in the network data set, for example, we might have different vendors represented, and that in itself can create bias. So we need to decide whether we're going to split those apart. If we are going to keep them in the same data set, we've got to decide whether we're happy with one having, if we're going to train that into a neural network, then one will be underrepresented. So I think bias is in every data problem, but you've got to consider what sort of bias, and therefore does it matter? And sometimes it doesn't, sometimes it does.
Okay, great. And Kez, same question to you, given the work that you're doing. How big of an issue actually is bias for the kind of work that you're doing?
So I think when it comes to working with real-time data streams, the biggest bias problem you have is that if you are collecting and labeling your anomalies using some method, and then you are using those labeled anomalies to construct a new method, you end up with a bit of a feedback loop in terms of what your method considers to be an anomaly. And sometimes it's good to maybe take a step back and start thinking, okay, what assumptions have I introduced into this pipeline through all of the various choices that I have made that have been sort of amplified and almost faded into the background as assumptions that never become questioned.
It's the unknown unknowns,
Yes.
to quote that famous phrase from back in the day. So just staying on the bias and fairness line for the moment. In Europe, we got GDPR, we got data protection laws to some extent in the US as well. And so there's lots of this data that's really not ethical to collect in the first place, which may add to the bias at the end of the day. So how do we overcome that within the kind of models that we're talking about, where we know we can't collect that data and use it effectively, to maybe use it to take bias out of the models, if that makes sense from that perspective. So we can't get access to it, but we may need it to unbias the models. I mean, so Merve, I'll come to you with that one first.
It's a hard one. Like I said, even if you collect it with all good intentions, it is hard to motivate that why you're collecting it, even if it's to reduce bias. And all of these regulations, not just GDPR, there's also extra regulations around financial services, for example. And there's also another layer that you really do not want to upset your customers. And even if you say, oh, this is for your own good, we are going to use it to remove bias or measure how biased our decisions are, it is quite hard to comprehend. So I don't think I have a straight answer for that, but the only thing I can kind of pose back saying there's different layers that we would need to go through, and it's not just the GDPR, and I am not sure what is the best way to motivate it and how to proceed. The other thing I was thinking, maybe we can try to use some proxies in a way, but then using proxies to measure bias at a personal level, how would it really work? How can they quantify their uncertainty so that proxy might not be a representative for that single individual? So we might actually be introducing extra bias on top of that. So it is a big challenge.
Okay. Ben, do you have any views? Once again, there's a lot of violent head shaking in agreement there. You got any views on that, Ben?
I think it's a really difficult challenge. I think a lot of this is the collection of data for ethical uses comes down to good communication, and good science communication is always difficult. We've seen it in the UK in recent years, where I feel we've probably done a poor job of communicating the value of healthcare data, for example, to the general public. We sit on a very vast collection of healthcare data that could be extremely useful for research, but being unable to really connect with people in a way that helps them understand the use of those data makes it very difficult for us to be able to go and use it ethically. And a lot of this really, it comes down to a basis of trust and transparency. And without transparency, people find it very difficult to understand technology. And talk about this sometimes, and the example I sometimes give is the adoption of the microwave oven. When microwaves were first invented, it took maybe 2 decades longer than it should have done for that technology to reach wide-scale adoption. And that's because people couldn't understand how on earth food could be heated without a heating element, so they didn't trust it. And so there was a communication issue that meant that took time. I feel like we're facing similar kinds of challenges, communicating complex data science principles to people who don't have any need to try and understand these things in order to allow us to access data ethically that can open up whole new fields for us.
Do you think, and just to the whole panel, do you think with what I would call the Facebook generation coming through, who tend to share everything, all right, whether it's TikTok, Facebook, or whatever, do you think we're going to see a change in people's willingness to share data in a way to where it may take bias out of systems in the future? And I guess, Sam, can I come to you first on that one? Because I know there's a societal change here that may impact this, but I'm not real sure if it's being included in the models or being thought through in terms of how we build some of the models.
I mean, look, I think the whole private data sharing thing, I think, first of all, the social media generation, I mean, maybe 5 years ago that was true, but I feel like increasingly I see that people, even young people, are becoming sensitive to the idea that they're being monetized by these platforms. And increasingly I see people being, less and less just posting their random personal details on these networks. And it's more about, they're people who are posting or have some, some agenda, or they're trying to build some kind of brand or something. But, this is just, it's such a hard problem. I think the other panelists got it right. I mean, what can you do about it? Well, I think you have to start when you start saying, I'm going to use an algorithm to make a decision, you better ask yourself, what biases am I subject to, and how am I going to construct an experiment that allows me to understand that I'm not? And, in the face of all these privacy regulations, what can you do? I mean, I think the suggestion, the one thing is, well, maybe you can go off and do a small scale study. You build your model, go off and, pay to acquire this data that would allow you to evaluate bias, on a small group of people. That's a difficult thing to do, but it's probably the kind of right thing to do. I think Merve's suggestion of proxies is a good one. You might be able to say, well, I've got data. I don't know who these people are I'm building the model on, but I've got some data about the geography that they're from, and I understand something about the racial demographics of that geography, and so I can show that there's not a geographic bias in my algorithm, and so therefore I can, maybe use that to provide a suggestion that there's not a racial bias. But this is, in the ways that Merve described, is fraught, and it's just. I think it's just something we have to be really careful with. So. Okay,
and Kez, I mean, don't take us the wrong way, but you are of a younger generation, I think, than.
I am a certified member of the Facebook generation. Yes.
Yeah, I mean, what's your take and view on this kind of willingness to share data?
So I think, like my fellow panelists said, it has changed a bit in the past 5 years or so. I think members of my generation are becoming a bit more aware of the fact that Facebook is maybe just because it's free doesn't mean it's not making money from you. I think probably the biggest impact this has in terms of debiasing and qualities of data is that even if you were to use a big, huge Facebook-generated data set of everything to try to debias your algorithm, no guarantees that's going to debias it, of course. The data in there is the quality of it of the correct way. And even if you were to attempt to debias it like that, you'd run into issues with actually the design of your algorithm such that what you're trying to make your algorithm replicate may have biases in the system that it's trying to replicate. And if you're trying to replicate that system well, you will replicate those biases, and you are going to need to have some difficult conversations about that in terms of, do we want to actually make our model worse in order to not racially discriminate.
Okay, great, thank you. And I guess, Trevor, from your perspective, I said, you and I are of an older generation. I don't know about you, I got my Facebook account seriously locked down and such, but do you have a perspective on this?
So I think what is true is regardless of whether people are generally happy or not to share data on Facebook, and as we've discussed, this goes in waves, I think you always have to look after the minorities, and i.e. those people who aren't happy to share it. So just because maybe a majority are, that doesn't mean you don't need to look after the interests and protect those who aren't. So.
Okay, no, fair enough. And I want to stay on this topic a little bit, because one of the other questions that's come in is, do we have any examples of when bias in a model has worked well and led to something important or useful? So, most of the press coverage is about, the negative aspects of this. So do we have any examples of where this has actually been helpful to some extent? So, Sam, can I start with you on that one at the end of the day? This is kind of a reverse engineered question, if you know what I mean.
Yeah, I'm just trying to think of some examples of this. I mean, I think that, at some level, when you're designing a model, right, you're often trying to, you're often trying to make the model be able to predict something about, small or unusual groups that don't happen that frequently, right? So you oftentimes, if you're trying to, let's see if I can come up with an example, figure out the, predict the, people who are most likely to, defraud your bank, right? The number of people who defraud your bank is actually very, very, very small, right? So if you're trying to use a machine learning, data set to do this, you actually have to sort of account for that bias in the data that you use to train the algorithm, right? So that it understands that the prior, on how frequently people defraud the bank, so that it doesn't assume that everybody who does something a little bit weird is committing fraud, right? So, it's not like bias is, all data has some kind of bias in it, and we have to figure out how we, work with that data and understand what the goal of the sort of algorithm is. I mean, the examples of network monitoring or similar things as well. There's you might have 90% Cisco devices and 10%, Huawei devices or whatever, right? And
yeah.
That's a bias in the data. I mean, I don't know whether it's, and your algorithm has to be able to deal with it and work with it. And you don't want to discard that bias from the data because it might very well be exactly the thing, related to the thing you're trying to understand or predict. So that's why this is just so complicated.
Okay, great. Thanks, Sam. And I guess, Merve, you work the insurance industry, so this has got to be a real problem for you guys, I suspect.
Yeah, I was thinking when Sam was giving an example, what good might actually come out if you find a bias in your model or in the data. One good might be if you're actually, because in insurance it's heavily regulated, even the people processes are very regulated not to discriminate against anyone. But the good thing that might actually come out for maybe other industries that do not have that much regulation, and if data scientists, say, building a machine learning model, looking into the data and trying to identify if there's any bias, and the training data that they're doing it on is based on human decisions, and they might actually identify some underlying bias in the ground truth by looking at finding a disparity between different groups, for example. And a good outcome might be that it can spark the conversation of, okay, what was the process beforehand, before the machine learning approach was applied? And that process may be actually biased, intrinsic human bias, not a model bias. So that might be actually a good example that can come out of a biased model or a biased data set.
Okay, great, thanks.
I thought of.
Yeah, Ben, any views?
I think I would agree with that. I think it's hard to think of a specific example of where bias has been a good thing, but I think working with data and understanding that all data is biased, it's almost like holding up a mirror to yourself And the fact that we go through these processes of trying to understand where our data might be biased means that we are confronting those biases in our processes. So particularly where those data have come from prior human judgment. And we've certainly seen places where taking the time to understand where those data might be biased has had some beneficial impact, because it means that the underlying processes have then been reviewed as a result.
Cool. Great. There's one more bias question. I want to move on to a couple of other topics. And this is this whole area of unconscious bias. So, you know, we build models, but how can we actually test and verify whether there's levels of unconscious bias in it? And if you're building models to test for that unconscious bias, how do you know those models don't have unconscious bias? And for me, it's kind of it's a regressive thing that potentially to some humans being humans. You know, we're trying to build, you know, a machine that thinks here. So how do you actually test and verify this to know, or is it not that important for it to be that accurate at the end of the day? And Kaz, I know this is a complicated one, but I'm gonna push this in your direction in the first place, and then Trevor, I'll come to you for an answer at the end of that as well.
So I think this relates a lot to how statistics are presented in the media. The whole lies, damned lies, and statistics saying is that you really, by the choice of which numbers you report, you can really shape the conversation on. You can shape the conversation and you can shape the story. And this is a problem because an awful lot of people don't have much maths knowledge, and they tend to see a number and they believe the number, and they certainly don't investigate the statistical methodology through which the number came from. And often what those numbers came from was someone said, oh, I want a number, I think it should be about this much. Give me a method that will give me a number about this much so I can put it in my story. And it's very, very important when looking at these news articles or even within a company to make sure you're doing data decision making and you're looking at like evidence-based policy rather than policy-based evidence here.
Okay, great. Trevor?
Right, so as Merve mentioned earlier, you know, in the network space, at least in the part I work with, we're not getting data from human processes. So we're not picking up data, as far as I know anyway, as far as I can think of, that has been, you know, biased already by human operation. However, you know, as I mentioned, we will suffer from under our representation of data in depending on the type of anomaly detection, for example, we're applying. So as I said, that would apply if we're training a neural net to recognize multiple vendors. If we're operating a time series detection, that time series is working within a single series, which is within a single vendor, and therefore it doesn't apply. The other place we do get bias is when we're sampling. So we do sample metrics from the network, and that in itself, therefore, unless we do, you know, perfect unbiased sampling, that sampling is biased, and we do see that. And we do, therefore, when we're trying to reconstruct things like averages, you know, the average performance of the network, the average performance of the KPI, we do go through processes such as stratified sampling and raking, statistical raking, which then basically says, okay, well, let's make sure, even though our sample wasn't across a range of broadband lines with totally representative speeds, we can then rake that data set, rake that result to make sure that each and every line has a bias weight against it, such that it then becomes resembling the overall population. So we do apply those sorts of techniques to remove bias from sampling, and that's another cause of bias is sampling.
Great, thanks, Trevor. And I guess, Merve, this is a potentially big issue for the insurance industry in terms of you know, the whole unconscious bias. I mean, how do you find this or detect it or even prove it exists, actually?
It's a quite hard one, even proving how it does exist. Like I said, it again comes down to, I think in simplistic form, identifying any disparities between any groups. If there's any visible disparities that a decision is favouring, for example, one group over another, And if so, why is this actually happening? What decision is causing it? And what are those groups? And how do we define those groups? I think these are the questions we do ask ourselves, and we do try to measure to a certain extent, not to be discriminating any groups, basically, especially the vulnerable customers.
Yeah, great. And Ben, do you have anything to add to that one?
I think it's a very difficult problem. I think a lot of what we do is about taking models of human expertise alongside data-driven models, where you're bringing in subject matter experts alongside a decision that's been made or a prediction that's been made. But even within kind of setting human price and building human models, there's still the risk, and that you might be introducing that subject matter expert's unconscious bias. It's a very difficult thing to manage and to cater for sure.
Okay, great. Thanks for that. Let me change tacks here slightly about building the models. So we're building all of these models for AI ML systems. Then we're also building models to test the AI and ML systems. But industry technology is moving at probably an unprecedented pace at the moment. How do we keep up with that? So just about the time you build your model, what's the chances that model may be out of date in terms of not only testing your model, but the model you have in the first place? So how do we keep up with the dynamics of the marketplace, the industry, the technology, and kind of what's going on in society to where these models are still valid? I mean, yeah, bias may come into it, but are they still valid models given that pace of change? And Sam, can I start with you on that one, please?
Sure. So I guess one thing that I've observed over the years of trying out a lot of machine learning models is, yes, there's always somebody claiming that the latest, greatest thing is so much better than what was there before. But, I think the reality is that for a lot of problems, the exact choice of particular model that you choose isn't all that important. What's the much more likely to influence whether your algorithm performs well or not is, do you have data that has some underlying predictive characteristic or attribute to it? And so if it's true that you could always be chasing the latest, greatest, shiny, next deep learning thing, but for most problems, good old tried and true algorithms that you developed 5 years ago are probably going to work just as well as new problems, and you're probably better off devoting your time improving and cleaning the quality of the data than you are trying to go for the newest, biggest, fanciest model, despite all of the tremendous buzz about deep learning and massive neural net architectures and et cetera, et cetera. Sometimes those matter, but I think in many cases they don't.
Okay, great, thanks. And Trevor, I know given the space that you're working in, as we keep modifying, changing the network, new technologies coming along, I'm assuming this is a bit of an issue for you guys, yeah?
Yeah, absolutely. So some of the techniques, I mentioned online, so some of the techniques, as well as just the continuous online streamed predictions, essentially they work in an online, they learn in an online fashion anyway. So there isn't any concept in those techniques of, having a model that gets stale. The model is continually updated each and every observation we see. There are other techniques such as the LSTM autocoder I mentioned, where yes, we are training periodically. And in that case, our retraining pipeline, whenever you have a retraining pipeline, you're going to assess the accuracy of that model before you put it into deployment. So you could just retrain that model periodically, assess whether it's accurate, assess whether it's significantly different to your existing model, and then deploy it. But also you can assess that accuracy up front before you then do your retraining. So you can look at, for example, in our case, the distribution of the reconstruction errors. We can look for shifts in that might be indicative, not the outliers, because they're anomalies which come and go. But the bulk of the distribution of the reconstruction errors, if that starts to shift, we can then use that as a metric to say, okay, we now need to kick off our retraining pipeline. So.
Okay, great. And Merve, insurance industry, this has got to be a constant issue for you guys as the demographic changes, the technology and, say, cars change and so forth.
Yeah.
How do you guys stay ahead of that curve?
A bit like what Trevor was saying about making sure the data drift is not too big, for example. It's also another change is, for example, the fraud behaviour. Like human behaviour might change. You might have COVID. So just to make sure that our models are actually valid and performing the way they perform. Obviously, they're constantly monitored from the business side. Some of the models are constantly retrained with the certain checks in place. But also we have monitoring in place to check the data drift if the data is very different or there's something unexpected going on that we really need to go and address. So we actually also refresh those models. And in terms of keeping on top of the new technology or state of the art and everything, I think we're quite lucky to have a collaborative partnership with University of Bristol, for example, and we're working with academics. They're also helping us to stay on top of the areas and trying new methods. But like Sam was saying earlier, the core is making sure our current models actually work, and if they actually keep working when they're in production. So we're trying to do both sides.
Okay, great. Thanks, Merve. And I guess, Ben, you guys have a similar issue with the kind of models that you're building for your AI systems as well at Rainbird, yes?
Yes, and I would echo a lot of what's been said. I think some of that is about making sure that your models in deployment are behaving in the way that you might expect them to. On the technology side, I mean, I'd echo what Sam said. It's in technology in general, it's always tempting to go and look for the latest, greatest, shiniest thing. You see it in the new set of libraries or programming languages that come along every other day, and the temptation to migrate your models over to some new framework is always very tempting. But it's important to understand what you're building these things for in the first place, and have good metrics that show that you're achieving what you're setting out to achieve, and only deviate from that or go and invest in spending time exploring new techniques if you've got a good reason to do so.
Okay, great. And I'm conscious of the fact we've only got about 2.5 minutes left, so I'll go to one final question, and I'll work my way around the panel with this one. And there's been some discussions today. I know Alex Healing touched on it earlier about autonomy in the systems. About do we have a human in the loop in terms of what these, the system's output, in terms of how we act on the data at the end of the day. Do we have a view about when some of these systems may become fully autonomous, i.e. no human monitoring or no human in the loop from our perspective, and what are the risks associated with that? I mean, for me, the risks are kind of obvious in one sense. It could go, it could go completely off the rails. I'm thinking, a lot of the general public have this view of like RoboCop and Terminator kind of stuff, which I think most of us will know is, quite a long way away, thank God. So what are the risks of going fully autonomous, and how far away is that? So once again, Sam, can I start with you on that one in terms of the autonomy question?
Boy, I think the risks are kind of clear, right? Which is like if you're letting an algorithm make decisions that are critical to your business, you better be pretty darn sure that those decisions that it's making are correct, right? And especially if this is an algorithm that is learning as it goes, you really run this risk of it just kind of going haywire. And we've seen some of these terrible examples of these things, right? This like Microsoft Tay chatbot that learned how to say terrible racist things because it was learning from what people posted at it on Twitter. So I think you have to be really super careful about this, right? I think as to when in particular domains we will be seeing full autonomy. I mean, I think it's going to vary a lot by a domain, right? Like you might be willing to have full autonomy in a setting where it's kind of relatively low risk. If you're making a decision about what ad to serve to somebody next on Facebook, maybe the cost of getting it wrong isn't that high. If you're having a fully autonomous system that flies an airplane or drives a car or does something that's critical to human life, it's going to be a lot longer before there's absolutely no human in the loop, despite what the Elon Musks of the world absolutely.
I was waiting for somebody to mention him. It's inevitable in a discussion like this kind of stuff, wasn't it? Great, thanks, Sam. I mean, Kez, from your perspective in terms of the autonomy. Oh, you're on mute, Kez.
It was going to happen sometime, wasn't it? I think looking at it from a more Internet of Things, sort of edge analytics perspective, the issue I find when trying to make things fully autonomous is that often the data you're monitoring is not stored unless you decide it is interesting and you should store it, because there simply just isn't enough storage space to hold the sort of high velocity data stream that you're trying to monitor. So the real risk here is that you lose access to the data that you didn't think was important. So if your choice of what data you thought was important was wrong, it's going to be very, very hard to undo that.
Great, thanks, Kez. And Ben?
So I think we are seeing some use cases that are becoming fully autonomous, but that only works if you have models of whatever regulatory framework or governance framework that you need to apply alongside your data-driven prediction or decision that can also take action and flag when things go wrong. I think it really does depend on the risk involved in the decision that you're making, and that risk can both be regulatory or reputational for an organisation, as in the Microsoft Tay example. So I think we're seeing some more of the kind of lower risk autonomous use cases being deployed now. We're seeing, for example, decisioning around credit card fraud transactions, whether or not it's safe to remove a block on a customer's credit card being run as a fully autonomous process, because the risk to the organisation there actually has to balance against whether a customer is going to carry on using that credit card versus them stomaching the cost of the transaction being fraudulent. So it's always going to be a risk judgment.
Great, thanks, Ben. And Trevor?
Yeah, absolutely. So I can certainly talk about network automation. So in my presentation, I talked about general unsupervised anomaly detection, much as Alex started his talk. And there we're detecting anything and everything. And then expert operators are using a wide variety of diagnostic tools to really decide what the root cause is and decide the right fix. So if we're going to talk about really automating that process, we need to break that apart, and that's exactly what Alex was talking about. Okay, well, out of that wide variety of things we can spot with unsupervised anomaly detection, can we start to encode specific things like a denial of service attack? If we can get the accuracy of that up, then we know that particular diagnosis and we can work on a particular fix for that particular diagnosis. So we start to chain through, these very specific examples that we start to automate. But automating the entire problem of anything and everything that can diverge from the normal operation of your network, no, we're a long way away.
Okay, great, Trevor. And the last word, Merve, over to you in this space.
I agree, all the fellow panellists. We're a long way away. It's very risky, especially in insurance, fully autonomous systems. I can't think of it at the moment. Maybe smaller, less risky fields that's not affecting the customer too much, but having human in the loop would always be crucial. There's also quite a lot of human element in certain cases. For example, if a customer calls to make a claim, if they're in a really vulnerable and bad situation, call handlers actually do a great job trying to calm them down, but I kind of cannot see it happening in any near future that a fully autonomous robot will take over that, and I don't actually ever see it happening, to be honest. But less risky areas, less human interaction needed areas, I think we'll see it coming more.
Great, yeah, because I was involved in a really interesting incident when autonomous vehicles was at its height in terms of the PR. And everybody was, oh yeah, I can't wait to get one, blah, blah, blah. And one of the BT data scientists stood up at an event I was running and said, never happened in my lifetime. And he was in his mid-40s at that stage. So he was going completely contrary to what the thought processes were at that time. So it's quite enlightening. So guys, thank you very much, everybody, for your time, for your presentations, your inputs on the panel, and so forth. So Sam, Ben, Trevor, Kez, Merve, thank you very much for your time. I'm going to bring the panel session to a close. Actually, I could probably go on for another half hour, but we're going to have to bring it to a close anyway. But so thank you very much for that at the end of the day. So this brings us to the end of day 2 of Data Science, the Beating Heart of AI. And we've got day 3 tomorrow starting at 9:30. He says, because he forgot to write it down on his script, starting at 10 o'clock. All right, we're starting at 10 o'clock tomorrow. And we're going to talk about, where's my model? Putting it all together and running the AI factory. So we've gone through the basics. We've got into a lot of other discussions today about bias and autonomy and so forth. Tomorrow is about how do we actually try to get it to make it to work in a realistic fashion. So on that note, I'll bring this session to a close, and hopefully we'll see you all tomorrow. Thank you very much.